G'day everybody. In this lesson we're going to talk about statistical inference. We're going to talk about how samples are used to find out population statistics. We'll talk about confidence intervals, how they help us deal with the uncertainty of sample calculations. I'm going to refer to something that we call the margin of error, and we'll think about what affects that margin of error. And during the lesson we'll see how we use the CAS calculator to get these statistics. So we've talked about populations and samples previously. In this example, let's say we're interested in the upcoming election. What proportion of Australians will vote for the Purple Party? So this is a very realistic type of example of where we would use this type of mathematics. So we're wondering about the value of the population proportion P. In our last lesson where we talked about this, this was actually a given constant. Today we're trying to take samples to find out this value. And so that's what we would do. We would survey a certain sample of that population. In this case, let's say I've sampled 40 people and they've answered, 5 of them have answered that they would vote for the Purple Party. And so straight away, this gives us a point estimate for the value P, the population proportion. So the sample proportion, 5 out of 40, is 0.125. And so our point estimate for this question is 0.125. This survey is only one estimate, and other surveys are going to vary somewhat from one to the next. We've already seen previously, you might remember this diagram that shows us how it pans out when we take a lot of samples. In many instances, our point estimates, our sample proportions are very close to the population proportion, so we can see a lot of outcomes, samples that reflect that they're close, but it's very possible at the same time that our sample is going to be very different, significantly higher or significantly lower than what the population proportion actually is. And so we deal with this uncertainty by providing a confidence interval along with the point estimate. So let's go back to our example. So thinking about the proportion of Australians that will vote for the Purple Party, if my survey shows that 5 out of 40 would, that's my point estimate. And along with that, I would provide a 95% confidence interval. And that's two numbers, a lower limit and an upper limit. So in this case, the lower limit is 0.023, the upper limit is 0.227. So while the point estimate is 0.125, actually the population proportion could be anywhere within those two limits. And so that accounts for some of the uncertainty. At the same time, it's still possible, and this is only a 95% confidence interval, it's still possible that the real population proportion is outside of those limits. So let's look at how I calculated that particular confidence interval. So we have P hat, and that's our point estimate that comes from our sample, and the standard deviation for that variable is P hat multiplied by 1 minus P hat, or the complement of that, divided by the sample size n, and we take the square root of that, and that gives us the standard deviation for the point estimate. And it's that standard deviation that I use to provide the lower limit and the upper limit. So you can see here a formula that is not nearly as hard as it looks. We've got our point estimate, we've got some value z, and there's our standard deviation that we've just calculated. So I've got the point estimate minus z times that, and the point estimate plus some value of z multiplied by the standard deviation. This is really similar to something we've seen not too long ago when we were calculating probabilities around distributions. This is like saying the probability that an outcome will lie between the mean and 2 standard deviations. If that z value was 2, this is a limit that shows 2 standard deviations either side of the mean. So we're using that same concept. That value of z depends on the confidence level that you choose. So you could choose a 90% confidence level, and that means we're going to use a value of z, in other words 1.645 standard deviations. 99%, we would use a little over 2.5 standard deviations. One that's very commonly used is the 95% confidence interval, and we use 1.96. Very close to 2, and I think I've mentioned before that when we're 2 standard deviations either side of the mean, we are referring to 95%. In fact, exactly 2 standard deviations gives us something closer to 95.45%, and that doesn't roll off the tongue quite as well as 95%. So we peg it back to 1.960 standard deviations, and that gives us a 95% confidence level. So in this example, let's look at how I calculated those 2 limits using that formula. So first of all, we know from the survey that our point estimate is 0.125, and the size of the survey was 40. So using those values in this formula for the standard deviation, I've calculated a standard deviation of 0.0523. We want a 95% confidence interval, so the z-score, or the number of standard deviations, is 1.960, and so there's our p hat minus z times the standard deviation, and the upper limit p hat plus 1.96 standard deviations gives us those 2 values, the lower limit for the population proportion and the upper limit for that proportion, for the 95% confidence interval. The CAS calculator does all of this for us as well. So we're going to use this time the statistics menu. We haven't used that menu before in this course. In that menu you'll find number 6, which is the confidence intervals, and within that submenu you'll find number 5, which is the first property z interval. When you use that function, it's going to bring up this box here, where we're going to input the results of the survey. 5 people, 40 people surveyed, and we also input the confidence level. 0.95 is default, that will come up without having to put it in, but if you want to change it you can, and you click OK, and it gives you these statistics for the confidence interval. So let's just have a look at what's provided there in that output. This part here reminds you of the calculation that you've just made. 5 out of 40 is our proportion, and we want a 95% confidence interval. So it's giving us the lower limit for the confidence interval, in this case the 6 decimal places. The upper limit, we had 0.23, which you can see it's more accurately 0.227489. There's our point estimate, p hat, which is 0.125, and this is our margin of error, which I'm going to refer to in a minute, and it's reminding us that n is equal to 40. So the margin of error is this part of the formula, z times the standard deviation. We've already talked about where z comes from, so multiplying that z value by the standard deviation is what we call the margin of error. An important part of that calculation is the sample size, and because it's in the denominator here, if we increase n, if we increase the sample size, that's going to reduce the size of the standard deviation, that's going to reduce the margin of error. So the short story is, if we take the biggest sample that we can afford to, and that gives us the best statistics. This is just quickly to show you how the size of the sample can affect the outcome. So I've just input two different surveys here. 5 out of 40, which has a point estimate of 0.125. 10 out of 80 has the same point estimate. But I want to compare the confidence interval and the margin of error. So here we've got the smaller survey, and we compare our margin of error first of all, and we can see that this is a larger margin of error than when I had double the sample size. And the confidence intervals are further apart than they are when I had a larger sample size in my survey. So a quick overview. We take samples because we want to find out a statistic, a proportion of the population. This immediately gives us a point estimate of that proportion of that population. Point estimates are not reliable, and so we can use a confidence interval to provide less uncertainty, and so we have a lower limit and an upper limit for that confidence interval. Between the point estimate and the limits of the confidence interval, we've got the margin of error. So the margin of error is either side of that mean or either side of that point estimate. So I'm going to finish the lesson by looking very quickly at this exam question that's been used recently. I'm going to give you a moment to read that question. Pause the video. So we have been given the confidence interval, a 95% confidence interval for a particular sample concerning the size of butterflies. How many butterflies are very large, and the question is asking us to determine what was the size of the sample just from the confidence interval. So let's look at what we've learned and how this can help us answer this question. I've represented that confidence interval on this number line here, our lower limit, our upper limit. If I look at the difference between those limits and halve that, that gives us the margin of error. Remember, there are two gaps between those limits and the point estimate. Those gaps are the margin of error. So we've got a margin of error of 0.0316. We could also refer to that as being a margin error of 3.16%. Finding the halfway point, or the average of those two limits, is going to take us directly to our point estimate. And so exactly halfway between those limits, we have a point estimate of 0.055. And so now we know all of this information just from the confidence interval. Our margin of error, which we have a formula for, is 0.0316. We already know the point estimate, so we've got a formula for that margin of error, and we know the point estimate. We've chosen a 95% confidence interval, and so we also know that our value of z is 1.96. And so now we can solve n, which is the size of our sample. I've just used the CAS calculator, and we get n is exactly 200, or actually not exactly, but close enough to be 200. I've taken it one step further than the exam question, because we know that the size of the sample is 200 and we've worked out the point estimate. We can also say that in that particular sample there were exactly 11 very large butterflies. So we've done some statistical inference. We've seen how samples are used to find out population statistics. We've talked about confidence intervals, how this helps us deal with uncertainty, what affects the margin of error between those confidence intervals, and we've talked about using a CAS calculator. Please complete the Google form, write down any questions you have, log your attendance to check your understanding.